Hello and welcome to the another session on the binary systems which we are working on. Last class or in the last session, we have seen for acetone plus methanol. Okay. This system, we have also seen the activity coefficient is greater than 1. It means it is forming a zeotrope. So this mixture is a zeotrope and these two are miscible also. And the boiling point of acetone is nearly around 56 and boiling point of methanol is around 65. Okay. In this session, in this particular session, already we know that we know how to create a stream containing this particular, what do you say, acetone and methanol. Now, let us go little ahead and check the flow of it, or rather, how do I flash distillate? Okay, let me remove this, what you call, yeah, so this is removed. And let me save this as, another session. Let me call it as 4, binary system acetone plus methanol. And I want to flash it. Okay, flash. Okay, let me see. Or rather, to do that flashing itself, I should know what is its bubble point, what is its dew point. So first of all, my requirement in this particular session, or first of all, what should I understand is that what is the, what you call, bubble point and dew point of this mixture. That if we can understand first, that means what is the bubble point and what is dew point. Again, in these two, there are two things here. There is pressure and temperature. If I know pressure, I'll find temperature. One more thing is that if I know temperature, I find pressure. Similarly, that means if I'm finding temperature here, by knowing pressure, it is known as bubble point temperature. If I know pressure and I'm finding temperature, that means I say it as bubble point temperature. Similarly, the pressure is known and I'm finding temperature, it is now dew point calculations. I say it is dew point temperature calculations. Now I know the temperature and I am calculating pressure. So here, what is calculating? Temperature. Here's pressure. Here, temperature. Here, pressure. Again, from the dew point perspective calculation, it is pressure. So dew point, pressure calculations. For any system, for any binary system, in fact, to flash, the pressure should lie between bubble point and dew point. Bubble point and dew point. Because in between these two pressures only, there will be we can see two phase. That means if we start with the liquid and at the extreme we have vapor, there is a zone where we can see L plus V. That means liquid plus vapor. So this is the theory behind the flash. Okay. Why bubble point is important? Why dew point is important? Okay. Let me actually erase all these things here so that we can simulate thoroughly in the simulation process window or process simulation window. See, we are in the Dwsim portal, which is free open source software. And I am trying to actually solve the simulations here. What you call, we should be thankful to, the inventor of the person, the inventor of Dwsim, who has given this particular tool to the entire world. Okay, entire world, right? So, yeah. So now, so to find bubble point and dew point first, okay. So what do I take is that in the results, that means wherever I am here now, I go to input data I go to stream conditions. I take this temperature, or for a better, yeah. So it's important first. Okay. I take this temperature and pressure. Instead of taking temperature and pressure, I tell it as pressure and vapor fraction. When I say pressure and vapor fraction, that means I know pressure, I'm finding temperature. Okay. Now the pressure is 1 atmosphere and the vapor fraction, if you see, it is 0. Vapor is 0. That means it is entirely liquid. Okay. It is entirely liquid. So there we find 55.8469 to be the temperature. It is calculated here. You can see here. It is calculated. That means what is it saying? It is saying something, right? Okay. Even if I am wrong, suppose somewhere I posted it wrongly or spelt it wrongly, you can actually correct me also. There is no issue. So the pressure is known 1 atmosphere. Okay. Pressure is known as 1 atmosphere. Now the vapor fraction is taken as 0. That means it is entirely liquid. That means we know the compositions of the liquid, mole fractions, and we are estimating temperature. What is the temperature now? It is 55.8469 degrees centigrade. So this is what we find out. Now if I say instead of vapor fraction 0, if I say vapor fraction 1, that means it is entirely liquid. Now it is entirely liquid now. Okay. When I say it is entirely liquid, entirely vapor, that means now in this particular case, we know that it is now vapor fraction is 1. That means we know yi. Okay. Now the temperature is 56.2337. Now you can understand this is again pressure is 1 atmosphere. Very simple. I make a change here in this particular vapor phase mole fraction. I choose temperature and vapor fraction like this. Okay. So in this particular video, we found temperature, fixing pressure, and we know whether it is a liquid or vapor. That means in the first case, I know pressure, I know liquid phase composition, I am finding temperature. In the second case, I know pressure, I know the vapor phase composition, I am finding temperature. Now I leave it to you. This temperature is known as what? Okay, this temperature is known as what? This temperature is known as what? Whether this is known as bubble point temperature or dew point temperature, or this is known as bubble point temperature or dew point temperature. I leave it to you. This is a very fundamental aspect. You should also understand. See, me telling while I am trying to make videos means of course, I have at least 0.01% knowledge, but it is not so. You also should find. First of all, take Dwsim, solve it, get the result, and find yourself. Yes, you are able to solve, you are able to find this temperature. Then you can post a comment on this here. Okay. Thank you very much. And I will see in the next video. That means in the next video, we will fix the temperature and we will find the pressure.